G'day, let's have a look at what's inside this battery-powered electric hair clipper. So we can see this is a coil inside, so that little coil of wire. So this tells us it's electromagnetically powered. It doesn't actually have a motor. And then I'm not sure what that is. It does have a little logo, so it's got ones and zeros there. It looks like a little chip, and then it's got A. So not sure what that A is trying to imply. Maybe AI or something like that, which obviously this thing won't have. This at most is just going to have a little microcontroller controlling a couple of components. But we'll open it up and have a look what's inside. So as I said, this is just a battery powered one. It's got the charging port down the bottom. You just charge this on USB, so 5 volts at 1 amp input to charge up that battery. You've got a nice on and off switch here, so it's a nice little lever. You pull that, takes a second, and then obviously that whole thing turns on. So when it's on, there's just a little indicator light, and blades then start oscillating back and forth, which actually does that cutting motion. We do also have this little lever here, so I'll put that up like that, and as you adjust this, it does have a bunch of different positions. So what that does is it just pushes this bottom blade backwards and forward. So that's in the most extended position, and then we can retract and pull that in and have it nice and close. So the reason that's there is, depending on how long you want that hair to be that you're cutting, you can leave those few millimeters in between there. And again, the way that works is I'll bring that up close, I'll turn it on and then just bring it up close. So you might be able to see that top blade almost disappears, right? Because it just oscillates so fast back and forth. You can't really see it, but if I turn that off, you can see that the two specific blades, it's got that top blade and the bottom blade. And what happens is the hair will go, I don't actually have any hair, but actually this might work. Got some cable here, so it'll work the same way. I'll just strip it a bit more. There we go. So we've got a little hair, right? Pretend that's hair. That hair comes in between those two blades, and then as that oscillates back and forth, it'll cut it and just chop that off. So I'll show you that. We'll put that in, turn it on. And there we go, that goes cutting that. It didn't want to start when I actually had the wire in. It was a little bit too strong for the magnet to actually pull it through, but once it is running, we can do that just fine and cut a little bit of wire. This is quite thin wire. I'm not really worried about dulling the blades too much. Obviously it will dull them if you do this too much, but with hair's a lot softer, so it'll cut that no problem. Before I go on, I'm actually just going to vacuum this up, because if you get splinters of metal bits, not sure if you've gotten that before, but I highly recommend you don't. It's an absolute pain in the ass. So just going to clean this up real quick and then we'll be back. All right, with that little demo over, may as well just actually dig in, take this apart and see what's actually inside it. I'll start with taking this blade off here. That should just take that off, and then it just has 4 screws, I think just Phillips screws on the side. And it looks like that whole front cover just pops off, so I'll get straight into it. Alright, so just taking these 2 blades off, we can see we've got that main blade on the bottom. So this is all metal. Both of these are metal, which is really good. Some of them you can get plastic or nylon ones, and then as they rub, they do wear out and they dull a lot faster than these. So if you are getting anything like this, I definitely recommend getting metal ones. This is probably a couple of years old and it's been used quite a bit and has no issues at all. So that's really nice. But you can see it's got that main bottom blade on the bottom, and then that's adjustable, so you can move that in and out. And then this top blade here is what actually oscillates, and then as it oscillates, it leaves those little gaps in between, so hair comes in and then it'll cut it, go further and actually cut that little hair. So that's really it. It's just the oscillation of these 2 blades that does all the cutting. So this is what's good, just to keep lubricated, because this will cause a bunch of friction, although it is very smooth, so minimum friction, but just to lubricate these parts as that gets used. And then here we can see that little pin there that just sticks out. So if I turn it on, you'll see that vibrate left and right. And as that vibrates, that sits inside this little nylon plastic injection molded bit. And that's what moves this around. So bring it up close and I'll turn that on. And there you go, you can just see that oscillating back and forward really quickly. So on some other models, you can actually get, they have a DC motor inside, and that DC motor will just spin around and then just have a little pin offset. So as it rotates, that pin will effectively, it's hard to show, but effectively spin like this. And then there'll be a similar sort of assembly like that will just convert that rotational movement into that lateral movement. So there's a lot more friction in those bits, and obviously a motor will have a moving part, spinning part, and is more complicated. Whereas this, again, I'll dig in a bit further, this will just have a little electromagnetic coil and a magnet, or at least an iron arm that'll just get moved back and forth to actually do that oscillation. So I'll just keep digging into it. There we go, so that cover just pops off the front really nicely. It's just an ejection molded bit of plastic, and then we've got that little see-through compartment just there to show off some of the function of it. But I'll probably dig into this a little bit more and then maybe let's have a better look. But we've just got the PCB here, there'll be a battery underneath it, and then we've got that coil assembly. This is all metal, a couple of springs on the side, and then we've got that actual rocking arm just here. So that's what's actually moving around or oscillating backwards and forwards to move that cutting blade. But there's a few more screws, so I'll take a few more bits out and see if we can get a better look at it. Okay, there we go. So we've pulled out all of the inner workings of it. So I'll just go through it bit by bit. On the side here, actually let's start on the other side first. So we've got a battery, looks like an 18650 battery, so a lithium ion rechargeable. They're usually 3.7 volts, so I would imagine this battery is also 3.7 volts, which makes sense because the charging current is just off a USB, or the voltage is off a USB. So we're gonna have 5 volts coming in. There'll be a couple little voltage regulators for the charge circuits, and then it's going to be charging that 3.7 volt battery at a little bit higher, so probably 3.89, maybe even 4 volts to actually charge this up. So that makes perfect sense. Just a standard 18650 battery, very commonly used batteries, so that's really good to see there. There's a capacitor on the inside, so 16 volt capacitor coming in on the input line. So that's probably just going to be doing a little bit of filtering of whatever comes in to just buffer that charge. And then right next to that, we've got an inductor there and a diode. So this whole thing is just going to be part of that input line. So as the voltage comes in from that USB, this is just going to be doing filtering, stabilizing that voltage. Then we've got a little controller just there, and that's most likely going to be the charge controller. So actually just managing that voltage to charge that battery. Then we actually have a whole bunch of other little surface mounted components. So all of these little chips, one of them is probably going to be the actual microcontroller that's going to be, so probably the big one here is going to be the microcontroller that's actually going to be doing the thinking and the processing behind this. And then a couple of these other ones here are most likely going to be transistor assemblies, so basically acting as switches to turn the power going into the coil on and off very quickly, because that's going to have to oscillate very quickly for this to work desiredly for that oscillation. Right next to that, we've got two very small surface mount inductors. So these inductors are sitting on each line, so on the positive and the negative side of the bigger coil up here. So they're just going to be acting as buffers for all of that energy flowing between the sensitive components on this side here and this big beefy coil, and just buffering that energy, just storing that little bit of energy when this is turned on and off as well, as any voltage comes back to it. So nothing too fancy really on this board, but it is a really nice board, well soldered together. We also have a little bit of celastic up here on these inductors, which is good to see. And then this little plate, or this little bit of fabric here, paper, actually not fabric, so this is just a paper, a waxed paper surface that just sits on top of here, which is a battery terminal. So we've got a battery negative terminal there, and then we've got positive terminal there as well. So that's just sitting there to prevent any sort of contact between that wire going into the coil and the actual battery terminal there, which is really good to see because this wire here is already insulated. So there's sort of a copper finish to it, or that shiny finish to it. That's just a liquid insulation that this wire is dipped in, and then that sticks on the wire itself. So that wire is already insulated, but that's really good to see. We've got this extra padding here as well, just to insulate it a bit more. So again, as I said, really impressed with this board. It's put together really well. All the solder joints look really good. And then we've got that bit of celastic there as well on the inductors, just because they're bigger components, so that'll just be holding it in place and also preventing any short circuits or anything like that. And then what we haven't looked at is just this switch. So this whole black assembly here is the switch. And it's really nice. It's just got this really nice rocker motion to it. So I'll turn it on. This will function fine, just turned on. This will just vibrate, but I don't think anything will fall off. But we'll see. So turning that on. Yeah, and back off. Nice and easy. So that works really well. It's just a very nice switch. And it's got that really nice feel to it as well, positive click. So that's good to see. They didn't just go with some cheap little thing. This has a nice feel to it. Down the bottom here, we just have simply the power coming in. So just the two prongs that sit on here, and then you put the cable in, and then that just goes straight into the board. Awesome. All right, so let's look at this actual assembly. So I might be able to open this up a bit more to get a closer look. I just want to be cautious of those springs coming off. Okay, there we go. That works really well. So this little A or AI, whatever we want to call this, I'll show that a little bit closer. It's quite a neat graphic, actually. That looks pretty cool. So that just sits on top. You saw that wasn't actually secured down anymore. So it does have two screws that do hold it on. And then those screws will go through this, through the main casing, and then into the actual plastic casing, into those standoffs. So that's nice that it just is actually held together in there. But once you remove that, then this comes off nice and easy as well. And then I'll take this off, and then we've just got that whole assembly there. So basically what it is a coil here, so a whole bunch of this wire wrapped around, and it does look like there's an iron core in there as well. So iron core is really good when you do want a stronger magnetic field. So when the electrical current will pass through this coil, it's going to generate that magnetic field, and the magnetic field will flow through that center of it as well. So we've got that iron core. It'll flow through that iron, and iron is really easily magnetized. So as that gets magnetized, all of the lines of that magnetic field will align really well through that iron, and the magnetic field will just get amplified. So that's good to see, because it is actually quite a small coil and it does have a lot of oomph to it. So that's good. This whole thing, yeah, as I said, is just going to be that coil, and then it's just taped off to hold all that wire together. And then this here, I'm not sure if that's actually a magnet in there. Yeah, okay, so that is a magnet. So we do have a magnet. Actually, I might be able to show that through this. So this is just a little magnetic paper, and you can see if I put that on top of it, those darker spots are just the two magnetic fields of that magnet. So if I move it around, you can see it moves. It's not just the paper. Maybe the other side will work too. So you can see it quite well there. We've got that one side here and the other side here. So what that means is that inside here is, obviously this is that magnet, that shiny thing. It is a rare earth, so it does look like a neodymium magnet, which is good because nice and strong. And then as this coil here would produce a magnetic field down the bottom, it would push this one way or another. And this little arm here, it is plastic, but it does feel like a glass reinforced plastic, so that's good, nice and stiff, which is what we want. It does pivot about this central point, which just has a little plastic bearing. Well, it's not really a bearing, but a plastic washer to act as a bearing, and then just a little bit of lubricant there. So again, enough, because that's going to move very little, so more than enough for this case. And then down the bottom, just an iron case that's holding that magnet in place. So effectively what happens is the magnetic field, or I'll take a step back, the current that gets passed through this coil just gets switched on and off really, really quickly. So not sure what frequency this will work at, but 50, 60 hertz, if not even more, a couple hundred hertz probably easily as well. That'll get switched on and off. As that current passes through the coil, instantaneously it'll generate that magnetic field, or a strong magnetic field, which will interact with that permanent magnet that sits just inside there. And then again, that's going to just push this arm either back and forth and just rock it back and forth. And then as that rocks back and forth, this is what we then saw before, sticking out of the bottom here. And then that attaches directly to this cutting head. So I think actually it sits in like that. There we go. So that attaches directly to that cutting head like that. This one sits, okay, actually, well, it doesn't like that. Maybe it's this way. How does that work? Ah, okay, this way. So that attaches directly to that, and then as that vibrates, obviously it moves that forward. So I'll just turn it on because I can show you that exactly. Oh, no, okay, never mind. That'll just disintegrate. What is it? Rapid unscheduled disassembly, right? With rockets. All right, close enough. So either way, that'll sit in there, that'll vibrate back and forth really quickly, and then cut up against there, here. So I'll bring this up again and just turn it on just so you can see that motion there. So that arm just vibrates back and forth really, really quickly. So the good thing with this, Now, so I've just got everything greasy and it's hard to turn it off because this is quite slippery now. So the good thing with this is it's all complete solid state. The only moving part is just that arm here, and all that moves is just that very, very little bit that wobbles around. And then we've got these two springs on each side that just always push it back and center it. So when that magnetic field is turned off, this just springs right back into the center. So the really good part about that is, as I said, everything here is solid state, except for that small arm, and that movement there is very little. So this is very unlikely to wear out over time. As long as you keep it lubricated here and don't get too much dirt or really little bits of hair in it. Little bits of hair will just eventually abrade all of this over time, but this is actually quite nice and heavy duty, so this will last for quite a while, provided you don't use it every day. It's not a commercial grade one, but if you just use this every couple of months for a haircut, trim your beard, whatever, this will be fine, no issues at all. So really good to see, really nice assembly, and then we've got a solid circuit board there holding everything together. As far as the case is concerned, it's nice, nothing special to it, but it doesn't really need to be anything. As long as it holds everything together, it gets the job done pretty well. The only thing you really want to make sure is that these screws here are quite long, so they do go quite deep into those standoffs there, so then they sit really well and hold all this together, because this does vibrate quite a lot. So if anything isn't screwed in place properly, or if there's any issues with the circuit board, if it's not soldered in properly, this will fall off, and that vibration will just kill everything. Vibration is no good at all when you're talking about electronics or even small mechanical bits. There we go. So that's what's inside of one of these electric hair clippers. So again, this coil up the top of this coil assembly will be very similar between battery and AC powered ones. This is obviously battery powered, so you do have DC current that is going through the board. So there does have to be some sort of switching or very fast switching on board to generate that frequency to oscillate or to turn that on and off, and effectively just have a switching supply to that coil. But if you did have a mains powered one, so instead of the battery here, you just have 240 coming in or 110 coming in, you would most likely be stepping that voltage down to a lower voltage, but you wouldn't actually have to turn the coil on and off with any sort of circuitry. And the reason that is because it's obviously AC current, it's alternating current, right? So you get twice in a cycle, it goes to a 0 point. So in that 0 point of current, the springs would counteract it and just push everything back together because the magnetic field wouldn't be there. So in an AC powered one, this would be slightly different. Most likely the coil would be a little bit bigger. The whole thing would probably be a little bit stronger as well. And then you would just have that AC coming straight into it. And as it oscillates, obviously with that sine wave, that would just be switching or doing the switching for you with the coil. Whereas on the DC side, DC, you obviously have that constant positive and negative, the direct current. So you do have to do that manual switching. And with that manual switching, obviously the components would be rated for it, but there's a high chance of it failing. So if you do want a long-term one, battery will probably be okay too, but an AC one might be even better because that AC will just come straight into the mechanical component of it. And the mechanical side of this is a lot less likely to fail than something in the little electronics, because eventually one of these components will let the magical smoke out and no longer work. But as I've said before, I've used this for quite a few years. Not every day, a couple of times a week maybe, and it's still in very good condition, so it works really, really well. Awesome, there we go. Thanks very much for tuning in. Hopefully that answers all your questions about how one of these things works. Leave a like if it did, helps out the channel. If you want to see more of this sort of stuff, then definitely don't forget to subscribe. Have a great one, and we'll see you soon.